Today I'm going to talk to you about the chain rule for finding derivatives. I introduced this to you in class today. Hopefully I will have a chance to do that to my fifth period class, but I did for my second period class. What the chain rule is all about is if you have a composition function, like if you have f of g of x, if you want to find the derivative of that, let's say y is equal to some f of g of x. If you want to find the derivative of that, you're just going to find the derivative of this outer function, whatever that may be, of the g of x. But then you also have to multiply it by the derivative of this inner function, whatever this inner function is, it will have a derivative. So you multiply that by g prime of x. Chain rule is often forgotten because a lot of times when students see a function like they don't recognize it as a composition as f of g of x, so they're just going to find the derivative and they're going to stop right there and forget about the whole second part of it. So this is the important part that's easily forgotten. Let's suppose that we want to take a couple of derivatives. Suppose you want to find these derivatives. Let's say the first one will be f of x is equal to x squared plus 3x, and the whole thing is squared. Well, probably the easiest thing to do would be to FOIL this with itself. So I'll say probably the easiest to FOIL with itself. So we'll have x squared plus 3x times itself. So x squared times x squared is x to the fourth, 3x plus 3x, and it'll be raised to the third power. So we'll have 6x raised to the third power plus 9x squared. So if you FOIL that out, that's what f of x is equal to. And the derivative of this function is really easy to find. With the power rule, it's just 4x cubed plus 18x squared plus 18x. So that was an easy one, and you wouldn't necessarily want to or have to use the chain rule on this one. Let's say we have another one. F of x is equal to, let's say it's x squared plus 3x again, but now we're going to raise it to the third power. Well, if you raise it to the third power, this would be one of those Pascal triangle kind of problems where you'd do the 1, 3, 3, 1, and you'd have x squareds next to all of them, but you'd have to take it up to the third, second, first, and 0 power. Then you'd have the 3x next to all of those, and you'd have to take it up to the 0, 1, 2, 3. You remember this hopefully from Algebra 2. That's just called a binomial expansion. And if you had enough patience, or maybe you're pretty good at binomial expansion from last year, you'd come up with f of x is equal to x to the 6th plus 9x to the 5th plus 27x to the 4th plus 27x to the 3rd. And then taking the derivative of that function with the power rule is pretty easy. It's just 6x to the 5th plus 45x to the 4th plus 52, I think that's 104, x to the 3rd, no, 54 and 54 is 108, x to the 3rd, and 27 times 3, 21, 2 times 3 is 6, I think that's 81 x squared. So it's a little bit more work if you wanted to use that binomial expansion. Let me, I don't think this is really focused all that well. There we go. So you could use the chain rule on this, or if you wanted to do that expansion and then just bring yourself down to a polynomial that you can easily use the power rule on, that might be easy. But what if you have something like this? F of x equals, we'll take this same thing, x squared plus 3x, but we're going to raise it to the 6th power. Well, if you want to raise that to the 6th power, again, you could use your binomial expansion with the 6th row of Pascal's triangle, which would have 7 terms, and you'd have to go through that whole thing again. But I would say forget this expansion. It's probably much quicker and easier to use a chain rule on this because we have a composition of functions. Or if you have something like the square root of x squared plus 3x being our function, you just don't have, without the chain rule, you really couldn't do that problem either. So I just am going through some examples where, you know, perhaps you wanted to use your algebra skills to get it down to one of these polynomials to take the derivative of pretty easily. But eventually you'll run across some problems where you'll just say, no, forget about it, I'm going to use the chain rule. So the chain rule says this, is if you have an outer function and an inner function, if you have, and I'll write this again, hopefully I will have a chance to do it in both classes. The chain rule says that if you have a composition of functions, f of g of x, you'll have an outer function and an inner function. Then, let's say y is equal to that. Oh, I already said that up there. Sorry, I'm repeating myself. So let's use the chain rule on A, B, C, and D from above. So let's use the chain rule on f of x is equal to x squared plus 3x, and the quantity is squared. So using the chain rule, we say f prime of x is equal to the outer function is x squared. And sometimes it's easy, it'll make it easier if you jot out what the outer function is. The outer function is x squared because you're taking something to the second power. And the inner function is the x squared plus 3x. So with this kind of terminology up here, you could call this x squared your f of x and x squared plus 3x your g of x. So if you want to take the derivative of the outer function, it's just 2x to the first, which is 2 times x squared plus 3x to the first power. But then you have to multiply it by the derivative of the inner function, which is 2x plus 3. In its own set of parentheses. And then if you wanted to find that in simpler, sorry, I'll have to catch this up in a minute. So now to finish up this problem, I guess the only other thing we could do is FOIL these two binomials together. So we have 2 times, let's see, 2x to the third, and 3 plus 6 is 9x squared plus 9x. And if you wanted to distribute the 2, you could, but that's a good final answer. So let's see if we got the same thing as we did before. Let's see, that would be 4x cubed plus 18x squared plus 18x. So this derivative matches this derivative, and they should, because we just did it, we found the derivative in a different manner back here. So this was part A, using the chain rule. Part B, using the chain rule, we had x squared plus 3x all raised to the third power, and we used the Pascal's triangle to expand that binomial. But if we wanted to use the chain rule, the derivative would be 3 times x squared plus 3x all raised to the second power. And then the chain rule says we have to multiply it by 2x plus 3. So if we wanted to try to get this derivative to match up with this one up here, we would FOIL this out, x to the fourth plus 6x cubed, it looks like, plus 9x squared times 2x plus 3. And then we could multiply everything by 2x. So we have 2x to the 6 plus 12x to the, to the fifth power, sorry, times 12x to the fourth power plus 18x to the third power. And then we could multiply everything by 3, excuse me, plus 3x to the fourth plus 18x to the third plus 27x squared. And it looks like we have a couple of like terms to combine. 12 plus 3 is 15x to the fourth. And 18 plus 18 is 36x to the third. And looks like that's it. So if we distribute the 3 throughout this parentheses, we have 6x to the fifth plus 45x to the fourth plus 108x cubed plus 3 times 27 is 81x squared. So hopefully this matches what we had when we expanded the binomial. Let's see, 6x to the fifth plus 45x to the fourth, 108x cubed. Yep, so that matches. So this is using the chain rule, and this is using binomial expansion with, with individual power rules for the terms. Letter C, we didn't do that one out, so we will do the chain rule on this. F of x is equal to x squared plus 3x all raised to the 6th power. So, whoops, that's f of x. So f prime of x would be equal to 6 times x squared plus 3x all raised to the 5th power. And I'm not going to expand that out. That'll take too long. And then part D, we had f of x equaling the square root of x squared plus 3x. So the derivative of the, and then we would write that as x squared plus 3x raised to the 1/2 power. And so the derivative of that would be 1/2 times x squared plus 3x. Oh, good grief, on the letter C I forgot the chain rule. See, even I forget that sometimes. 6 times x to the fifth, and then you have to multiply that by 2x plus 3. Sorry. Make sure you use the chain rule like I forgot. Now part D, 1/2 times x squared plus 3x to the negative 1/2 power, and then you'd have to multiply that by 2x plus 3, the derivative of the inside. So if you simplified this up, cleaned it up a little bit, you would have 2x plus 3 is in the numerator, because that doesn't have any kind of exponent on it. And then this 2 goes in the denominator, and this is the square root of x squared plus 3x. So there's your derivative of that part D. Excuse me. The paper. Let's do a couple more examples here. Let's use some examples using the chain rule. Let's say f of x is equal to 1 over 4x minus 3. Well, we could use the quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. That's one way to use the quotient rule. We could also, it might be a little bit easier if we rewrite this as 4x minus 3 to the negative 1 power, and then just use the chain rule to take that derivative. So f prime of x is equal to, bring the negative 1 down front, negative 1 times 4x minus 3 to the negative 2 power. That's the outer function, and the inner function is 4x plus 3, so we would have to multiply that by the derivative of 4x minus 3, which is just 4. So if we clean this up a little bit, we would call this f prime of x is equal to negative 1 times 4 is negative 4, and then 4x minus 3 to the negative 2 goes to the bottom. It becomes 4x minus 3 to the 2nd power, and we would leave that one like that. Excuse me. Let's see what other examples we have here. Oh, let's do an example where we have to use the product rule. Here's your next example. Let's say f of x is equal to x squared times 2x minus 3 all raised to the 4th power. Please don't even think about distributing the x squared into this binomial because it has an exponent on it. You couldn't do that. You just have to leave it like this. So if you wanted to use, or you would have to use the product rule to find the f prime of x. So the product rule says it's the first times the derivative of the second, or plus second times the derivative of the first. I think how I taught it to you is you take the derivative of the first factor first. So it's the derivative of x squared is 2x. And then you would write 2x minus 3 to the fourth power out. So the derivative of that times that. And then you'd have to add to that the second times the derivative of 2x minus 3 to the fourth. Well, the derivative of 2x minus 3 to the fourth power would require a chain rule. It would be 4 times 2x minus 3 raised to the third power, but then you'd have to multiply it by the derivative of 2x minus 3, which is 2. So if we clean this up a little bit, I don't think we're going to clean that first term up at all. We're not going to expand 2x minus 3 to the fourth power. Take too long. But we can multiply x squared times 4 times 2 and get 8x squared. And then 2x minus 3 is raised to the third power. Actually, let me show you one more thing in case you ever encounter this and you'd have to look for something to be factored. I hope you see that we have a common factor of 2x in each term. So we can bring 2x out in front of the parentheses. We'll pull those out. But the other thing we also have as a common factor is 2x minus 3. And in fact, we have 2x minus 3 raised to the third power in each of those terms. So we have a big GCF here we can pull out. And then what we're left with is if we take that factor out of that term, we're just left with 2x minus 3 to the first power, because we've taken 3 out of them. And then you would add to that 8x squared divided by 2x is 4x. And we've already taken the 2x minus 3 out in front. So we would be left with this times 1. And then one more thing we could do is we could add 2x plus 4x and get 6x here. So we have 2x minus 3 raised to the third power. 2x plus 4x is 6x minus 3. So that would be the simplified answer. And you should be able to do that if you had to maybe match up a multiple choice question. So I think that's probably a good enough introduction for you to the chain rule. You can use the chain rule within a product rule if you have to. Probably some of the problems I'll give you next time I see you in class, you'll have a quotient rule that you'll have to use, which will include a chain rule. So sometimes chain rules get embedded into other rules that we've already used. Hope you have a good weekend, and I'll see you next time. Maybe Monday, maybe not.